Welcome to Pomodoro Joe for Tuesday, May 23rd, 2023. Today we're looking at LeetCode problem 703, kth largest element in a stream. This is an easy problem. Design a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order, not the kth distinct element. Implement the kth largest class. Kth largest int k. All right, initializes the object with an integer k and the stream of integers nums. Int add int val appends the integer val to the stream and returns the element representing the kth largest element in the stream. Okay, seems pretty straightforward, so we'll put 25 minutes on the Pomodoro timer and we will get started. So for this, in our initialization, we get a k and we get nums. So we'll need to store these in our object here. So self.k is equal to k, and I'll call it stream, is equal to nums. Now I could just set it equal to nums, but just to be a good citizen, I'm going to set it equal to nums.copy. So we're not actually taking the nums and holding onto a reference. We're going to make our own copy of it here. Okay, that seems pretty straightforward. Now in our add, anytime we add something, we'll have to sort. So I'm going to take the easier route here. We're just going to do this very straightforward. We're going to store our stream and our k. Then anytime we have an add, we'll add this value to our stream. We'll sort the entire stream. Then we'll return the kth value in that stream, or the kth largest value in that stream. All right, so first we need to add our value here. So self.stream. I missed the R here. Self.stream.append this value. Next, we'll sort the stream. So self.stream.sort. And since we want the kth largest value, and this is sorting from the smallest to the largest, I'm actually going to do a reverse sort. So we'll set reverse equal to true. And then finally, we'll return our self.stream at index k. So this will be the kth largest value. Actually, index k will be the k plus 1th largest value because our k is not 0 indexed, but our stream is. So we actually have to do k minus 1. So in fact, up here, let's just do that minus 1 one time, and then we don't have to do it every time. So I'll call this the k index. That'll be k minus 1. And then down here, we can do k index. All right, so I think this is it. We will store our k index, which is k minus 1. Then we'll store our stream as a copy of the initial numbers. Anytime we add a value, we'll add the value to our stream. We'll sort it in reverse order so that the largest numbers come first. And then we'll return our kth indexed element in our stream. We actually need a self here as well. All right, so I think this should do it. Let's give it a shot. And that works. So let's submit this and see how we do. Now this is not the most efficient way to do it, but I think it should pass. And we do, we pass. We only beat 6% for runtime and about 6% for memory. So this is not great, but we do understand how it works now. So let's jump back to our code. All right, so what else can we do here to speed this up? Well, one thing we're doing is we're actually doing this sort every single time. That is going to be a slow operation. That's going to be an n log n operation. Now, instead of sorting all of the values every single time, if we could just insert our value into our array or our stream at the proper place, that would save us a ton of sorting time. Luckily for us, Python provides something called a heap. Now the heap will actually do exactly that. Anytime you push something onto the heap, it will find the proper insertion point and insert it into our heap. That'll save us a ton on our sort here. So let's create a heap. So to do this, we use the heapq library, so heapq, and we heapify our heap. So that's going to be self.stream. Now this is a min heap. Now a min heap means that the minimum value will be at the top of the heap. And what we're looking for is actually the max heap. So that's going to be a little bit of a problem. So one way to get around this is actually to limit the size of our heap to k elements. If we only keep k elements in the heap, then our minimum element will be the kth largest element. So let's do that. We're going to keep our k here. All right. So we've created our heap. Now come down here. In our add, first thing we'll do is we'll use the heap push. Instead of just adding it to our stream, we'll actually use the heap operation to push it onto our stream. So heap q.heap push. We pass in our stream. And we pass in the value. And now we need to limit our heap to only k elements. So this is a little bit tricky, but we can just say, while the length of our stream is greater than k, while the length of our stream is greater than k, we'll pop elements out of our stream. Now, again, since this is converted into a heap, we'll have to use the heap operation for this. So we'll do a heap pop. So heap q, heap pop, and we'll pass in our stream. And finally, at the end, we'll have a heap that is exactly k elements in size, which means that we can return the top of the heap. All right, so I think this should do it. Let's give it a shot. Okay, that works. Let's submit this and see if it gives us any improvements. That is a significant improvement. Wow. We went from a, what was this down here? 6% for runtime and 6% for memory to a 98.22% for runtime and a 17% for memory. That is a huge improvement. All right. All right, well, that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something, maybe a little something about heaps. Hope you can go out and write better code.